Fractions. Fraction is a number that represents part of a whole. It is consisted of a numerator and a denominator. The numerator represents the number of equal parts, and the denominator represents the total amount of parts that make up a whole. A fraction has two parts: a numerator and a denominator. Fraction is a part of a whole. For example, slice of pizza, and we get fraction. Let's look at the given picture. Calculate fraction of the colored rectangle. Step 1. First count the total number of parts in rectangle, that is 9. So write it in denominator place. Step 2. Second step is to count the colored parts, i.e. 3. So, write it in numerator place. Step 3. Now simplify the fraction. Adding fractions with different denominators. To add fractions with different denominators, you need to change the fractions so they have a common denominator before adding them. To find a common denominator, you can either find a common multiple, or you can multiply each fraction, top and bottom, by the denominator of the other fraction. Here's an example of the latter. Since the denominator of the other fraction is 3, we multiply both the numerator by 3 and the denominator by 3, which gives us 1 by 2 equals 3 by 6. This works because if you multiply both the numerator and the denominator by the same number, the fraction will have the same value. Since the denominator of the other fraction is 3, we multiply both the numerator by 3 and the denominator by 3, which gives us 1 by 2 equals 3 by 6. This works because if you multiply both the numerator and the denominator by the same number, the fraction will have the same value. Now we have 3 by 6 plus 1 by 3. Let's do the second one, 1 by 3. We multiply both the top and bottom by 2, the original denominator of the first fraction, giving us 2 by 6. So our equation is now 3 by 6 plus 2 by 6. Now add them up and we get 5 by 6. Adding more than two fractions is simple. If they all have the same denominator, just add all of the numerators and put the result over the denominator. Addition and subtraction of more than two fractions with different denominators. The addition and subtraction of more than two fractions is similar to the process of addition and subtraction of two fractions. For example, Verification of commutative property of addition of fractions. For example, associative property of addition of rational numbers. Verification of associative property. Definition. The associative property states that you can add or multiply regardless of how the numbers are grouped. By grouped we mean how you use parentheses. Add some parentheses anywhere you like. Examples of the associative property for addition. The picture below illustrates that it does not matter whether or not we add the 2 plus 7 first, like the left side, or the 7 plus 5 first, like the right side. For example, properties of multiplication of rational numbers. The properties of multiplication of rational numbers are closure property, commutative property, associative property, existence of multiplicative identity property, existence of multiplicative inverse property, distributive property of multiplication over addition, and multiplicative property of zero. Closure property of multiplication of rational numbers. The product of two rational numbers is always a rational number. If A by B and C by D are any two rational numbers, then A by B times C by D is also a rational number. For example, commutative property of multiplication of rational numbers. Two rational numbers can be multiplied in any order. Thus, for any rational numbers A, B and C, D, A by B times C by D equals C by D times A by B. For example, associative property of multiplication of rational numbers. While multiplying three or more rational numbers, they can be grouped in any order. Thus, for any rationals A by B, C by D, and E by F, we have existence of multiplicative identity property. For any rational number a by b, we have a by b times 1 equals 1 times a by b. A by b. 1 is called the multiplicative identity for rational. For example, consider the rational number 3/4. Existence of multiplicative inverse property. Every non-zero rational number a by b has its multiplicative inverse b by a. Thus, a by b times b by a equals b by a times a by b equals 1. B by a is called the reciprocal of a by b. Clearly, 0 has no reciprocal. Reciprocal of 1 is 1, and the reciprocal of -1 is -1. For example, distributive property of multiplication over addition. For any three rational numbers a by b, c by d and a by f, we have multiplicative property of 0. Every rational number multiplied with 0 gives 0. Thus, for any rational number a by b, we have a by b times 0 equals 0 times a by b equals 0. Dividing fractions. Invert and multiply. To divide fractions, take the reciprocal, invert the fraction of the divisor, and multiply the dividend. This is the quickest technique for dividing fractions. The top and bottom are being multiplied by the same number, and, since that number is the reciprocal of the bottom part, the bottom becomes 1. Dividing anything by 1 leaves the value anything the same. Dividing fractions common denominator. There is a lengthier way of dividing fractions, and it could be said to be a more correct method. It involves the use of equivalent fractions to make the denominators of both fractions the same. This is the correct way since, strictly speaking, you can't divide apples by oranges in the same way as you can't divide fifths by fourths. Dividing mixed numbers. Let's review how to divide fractions. Here is an example. We can use the KCF method. This stands for keep, change, flip. Keep the first fraction. Change from division to multiplication. Flip the second fraction over. We can use these same steps when working with mixed numbers by adding one step in the beginning. That extra step is to change from mixed numbers to improper fractions.